Another object from beyond our Sun has entered the solar system. It's called 3I ATLAS, and it is only the third interstellar object ever discovered. What makes this one extraordinary is not just its origin, but the fact that, for the first time in history, a spacecraft already in place might be able to intercept it. That spacecraft is NASA's Juno probe, currently orbiting Jupiter. A new proposal from a team of scientists suggests that with the right maneuvering, Juno could meet this alien visitor in March 2026. If successful, it could give humanity its closest and most detailed look yet at an object born around another star. 31 ATLAS was first spotted on July 1, 2025 by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, operating from Rio Hurtado in Chile. Follow-up observations quickly confirmed it was moving too fast to be bound to the Sun, placing it on a hyperbolic trajectory through the solar system. It joins the ranks of two famous predecessors, Oumuamua, discovered in 2017, and Comet 2I Borisov in 2019. Like them, it is traveling on a steeply inclined retrograde path, tilted about 175 degrees relative to the planets, with an eccentricity over 6, clear evidence it will not remain in our neighborhood for long. Its perihelion, the point of closest approach to the Sun, will occur in late October 2025 at a distance of roughly 1.36 astronomical units between Earth and Mars. Then it will swing back outward, passing relatively near Jupiter in March 2026. Early estimates of the object size, based on its brightness, suggested it might be a staggering 20 kilometers across. It had the dark surface typical of many comets. But more recent observations from the Hubble Space Telescope, taken on July 21, 2025, have revised that dramatically downward. The new upper limit for the nucleus is about 5.6 kilometers, and it could be much smaller, possibly less than a kilometer across. Even so, it is already showing signs of activity, with a coma of gas and dust streaming away, which means it will be a prime target for both ground and space-based telescopes in the months ahead. Why go after it at all? Interstellar objects are time capsules from other planetary systems. They formed around distant stars and rejected into the galaxy before eventually drifting into our part of space. Their chemical fingerprints, ratios of water-ice, carbon monoxide, carbon dioxide, ammonia, and other volatiles hold clues about the conditions in those alien systems. A spacecraft flyby can measure these directly, adding context that even the most powerful telescopes cannot provide. For 3I ATLAS, Hubble is already studying its coma, while the James Webb Space Telescope began infrared spectroscopy on August 6, 2025. But a close encounter could reveal fine details of its surface, thermal properties, and how it interacts with the solar wind. This is where Juno comes in. Launched in 2011 and in orbit around Jupiter since 2016, Juno carries a suite of instruments capable of probing a comet. Its infrared mapper, ultraviolet spectrograph, microwave radiometer, magnetometer, plasma and particle detectors, and wide-angle visible camera can together build a full physical and chemical profile of a small body. Juno was designed to survive Jupiter's intense radiation, and in its extended mission, it has already flown past several of the giant planet's moons. Now, with the right maneuver, it could leave its looping polar orbit and set course to cross paths with 3I ATLAS. The proposed plan involves a Jupiter-Oberth maneuver, firing the spacecraft's engine when it is at its closest point to Jupiter, where its orbital speed is greatest. Doing so magnifies the effect of each meter per second of velocity change, allowing Juno to pick up much more energy than it could elsewhere. The team's calculations show that a velocity change of around 2.7 kilometers per second, executed in September 2025, could reshape Juno's trajectory to intercept 3I Atlas in mid-March 2026. Just 2 days before the spacecraft currently scheduled end-of-mission plunge into Jupiter's atmosphere. The idea is elegant, but it faces major technical hurdles. Juno's main engine, Aelaros 1B, has not been used since 2016, when engineers discovered a stuck helium check valve. Since then, all orbital adjustments have been made with much smaller thrusters and large burns have been avoided. Whether the main engine is still capable of delivering such a powerful maneuver is unknown. There is also the question of remaining propellant. NASA has not publicly stated how much fuel Juno still has, but late mission trajectory changes have been tiny. On top of that, Juno has endured years in Jupiter's radiation belts, and every extra operation comes with increased risk to aging systems. If these obstacles could be overcome, what might we learn? Juno's infrared and ultraviolet instruments could map the comet's hotspots and measure the gases being released. Its microwave radiometer could peer beneath the surface to study temperature gradient and particle sizes in the dust. Magnetometers and plasma instruments could observe how the comet's coma interacts with Jupiter's magnetosphere and the solar wind. Even Junicum, designed for public outreach, could capture valuable context images, though resolving the nucleus itself would require an extremely close pass on the order of a few thousand kilometers to get more than a handful of pixels across its surface. Beyond the science, the proposal has attracted attention because one of its authors, Harvard astrophysicist Avi Loeb, has speculated that some interstellar objects might be artificial. In the case of Oumuamua, Loeb suggested it could be a defunct probe or light sail from another civilization, and in his recent writings he notes that early size estimates for 3I Atlas were unusually large. The new Hubble constraints make it look far more like an ordinary comet, but Loeb argues that the possibility, however remote, is worth testing. The vast majority of astronomers expect it to be natural, and a close-up investigation could settle the matter definitively. Time is short. 3I ATLAS will reach its closest point to the Sun in late October 2025, giving astronomers their best chance to study its activity from afar. The flyby opportunity for Juno would come in March 2026, but any maneuver to set that up would have to happen months earlier, before Juno's current mission and date. The decision to attempt it would require NASA to weigh the scientific return against the risks to the spacecraft and the costs of extending its operations. Whether or not Juno is sent to intercept, 3I ATLAS will be one of the most closely watched comets in history. Telescopes on Earth and in space will track its path, study its gases and dust, and compare it to the other interstellar visitors we've seen. If Juno does make the attempt and succeeds, we will for the first time be able to examine an interstellar object up close, potentially rewriting what we know about how planetary systems form and evolve across the galaxy. And if, against all odds, it turned out to be something made, the implications would be beyond anything we have ever faced.